Electronics and 2. The topic of today is chapter 2, the alternating current. So we are going to explain some of the things there. What is important in that chapter? The learner must be able to do the calculation of the instantaneous value, do the calculation of the mid-ordinate, and the calculation of the RLC second. So we're going to start with the instantaneous value. With the instantaneous value, but first, before we go to the calculation, we have to understand what is the alternating current. So alternating current is a current flowing in both directions. Graphically, to explain that, we are using a sine wave. Here is a sine wave. This sine wave is flowing on the positive end and the negative. As we say, it's a current flowing in both directions. The current can flow from the positive to the negative and also negative to the positive. With this sine wave is the one that we're going to use to do that calculation of the instantaneous. But first, as a learner, you must be able to label this sine wave. So to label it, when you measure from here, we have a 0. When you measure from 0 to your peak, we call this a peak value. We call it the maximum value. And also we call it the amplitude. Remember, the amplitude, we're talking about the height that is measured from 0 till to your peak. But when we measure from the positive to the negative, we are talking about peak to peak. But when we measure horizontally, then we are talking about the period, we are talking about the cycle. Talking about the period, we have to think about the time. To measure a time, T, we say is 1 over the frequency. But what if you need a frequency? Then you just manipulate in mathematics. If you have is equals to, you cross. Therefore, your F, it should be 1 over T. So with this sine wave, you can give yourself some values. Here, for example, if I have 20 volts and also here I have 20 volts. This 20 volts is your peak, it's your amplitude from 0. Your peak where it ends is that 20 volts. So the formula that we're going to use in instantaneous value by using this sine wave, we have two formulas where E is calculating the voltages. The formula is E, the E maximum sine 2 pi ft. This is representing the voltage. The other one we have I is representing the current. Is the I maximum sine 2 pi ft. As a learner, you must be able to differentiate the two. This is representing the volts. That's why we are using the symbol E. This is representing the current. That's why we are using a symbol I. There is another way we can write this formula. Here again, it can be E maximum sine Wt, or you can write it as a E maximum sine theta. These three formulas, they represent one thing, but I write them in different ways. What is this W? We call it an angular velocity. It's calculated by saying is 2 pi ft. That's why it's representing that. The three formulas, that's why I say it's a one thing. What is theta? Theta is calculated by saying is Wt. This again is still representing that formula. That's why I say the three formulas, you can write it differently, but they're explaining one thing. Same apply with the current, you only changing the symbol. It's going to be the I maximum sine Wt, and again it's going to be the I maximum sine theta. Also the three, we are talking about the one thing. So we are going to take one example under these formulas of the instantaneous value, where you are going to calculate the RMS, where you are going to calculate the average, where we are going to calculate the form factor and the crest factor. But before we come to those calculations, let's take one example from our exercise, or one problem from the exercise, to see how we can apply this formula where you calculate the instantaneous value. From our exercise, from our exercise here is the exercise 2, number 3. They say E is 22 sine 942.6 T. And the question there, the first question will calculate the amplitude. Second question, the maximum and the frequency. And D, E at 2 milliseconds. How will I calculate the following? You must remember your original formula. Take the original formula is E is equal to E maximum sine 2 pi ft. Below the original, write what is given. It's E is equal to 22 sine 942.6 t. So that we are able to see for E maximum it stands for what? For 2 pi f is equal to what? It's easier in that way, you never get it wrong because this is representing the original. So you can answer your question by remembering your sine wave. In your sine wave, I said from 0 to your peak, we are talking about the peak value. From 0 to your peak, we are talking about the maximum. From 0 to your peak, we are talking about the amplitude. Meaning the 3, the value there must be the same because they are representing one thing. So the first question there is saying, how much is your amplitude? Then you check your equation here. 22 stands for my E maximum, meaning the maximum amplitude and the peak is the same thing. My amplitude to answer there is equal to 22 volts. Answer for the second question, how much is your maximum? As we said, amplitude, maximum and the peak is the same thing, meaning also my maximum is still equal to 22 volts. But what about the frequency? Where is my frequency? You compare the two now. The frequency is up here where we have 942.6. To answer that number C, to calculate your frequency, remember here 942.6 is equal to 2 pi f. 942.6 is equal to 2 pi f. So you have to make f subject of the formula. Therefore, we have to divide by 2 pi, divide by 2 pi. Therefore, your f is equal to 942.6 divided by 2 pi. So I don't have a calculator. If you have a calculator, then you will calculate and find how much is your answer. The last question to calculate is say calculate E at 2 milliseconds. Once you see S as a second, you have to think about time. Meaning when you see T, you are going to substitute by that 2 milliseconds. But what is this M? The M for you is a submultiple where you're going to multiply with, which is a milli, is an exponent minus 3. So you're only going to take this and substitute where you see time. You take our formula to answer number D. E is 22 sine 942.6. The time is given as 2 times 10 minus 3 seconds. But now, your final answer must be in decrease. To be in decrease, remember in mathematics to convert, we have to multiply by 180 over pi, which is 57.3. So you can put a big bracket here, do your calculation, and you will find how much is your E. So this is how we are doing the instantaneous calculation of the voltages and of the current. The difference is only the symbol that we're using. For the volts we use E, for the current we use I. If here it was I, then when you do your calculation, you're supposed to use the symbol of I. So from here, again, we are going to do the form factor and the class factor. So if we check in our formula sheet here, we have those formulas for the RMS and the average, where the constant number is given for the RMS, which is 0.707, and the average, which is 0.637. Form factor is RMS value over the average, and the class factor is the maximum value over the RMS. So I'm going to take another problem where we are going to deal with the calculation of the RMS, the average, the form, and the class factor. Again, from our exercise. Okay. From our exercise now, we are going to do number 5. We are going to do number 5 from our exercise 2. Make sure you are writing down the data that is given so that you know what you have, what you don't have. Number 5, they're talking about the sine wave with a maximum value. We have the maximum value here of 220 volts and the frequency of 50 hertz. The frequency of 50 hertz. And they say calculate the effective value, the average, and the form and the crest factor. Talking about the effective, we're still talking about the RMS. It's another name that is used for the effective. Things that must be calculated. You calculate the RMS value, how much it is. You calculate the average, how much is the average. You are going to calculate the form factor, and you are going to calculate the crest factor. As I already showed you, the formula to calculate is the following. For the RMS, we have the constant number that is always there, is always given. So to calculate that, what we need is only the maximum value. So to answer the first question, to calculate the V RMS, it will be 0,707. You multiply it with the V maximum. We are talking about the voltage. The SI units are very important. It will tell if it's the voltage or the current. So here you will calculate, it's 0,707. You multiply with the V maximum. From your data is given as 220 volts. Then you do the calculation and you find the answer. Number B, calculate the average. The average value, also we have the constant number from our formula sheet, is given as the V average is 0,637. You multiply also by the V maximum. Then we have 0,637. The V maximum is still the same, which is 220 volts. And therefore you will find how much it will be. It's always like this when it comes to RMS, the constant number, and when it comes to the V average. With the form factor, then we apply the formula there. It's your number C. The form factor from our formula sheet is equal to the RMS value we divide by the average value. So you calculate them. The answer that you find here are the one that you will substitute there and you get your answer. But with the crest factor, also from the formula sheet, the crest factor from the formula sheet they say is the maximum value. Then you divide that with the RMS. Then you will get your answer. After you do your calculation, if you find this one it will be 1.11 and you find it if this one will be 1.414, know that you are dealing with a pure sine wave. If it's less than these values, you are dealing with a flat wave. If it's greater than this value, you are dealing with the peaked value. So this is all under the instantaneous, the formula that you have to know what you must do in the instantaneous value together with the average RMS form.